Hi. I recently did an interview with Zach Cross, who is our junior designer in residence. Zach just recently graduated from Temple University. He's a very energetic young designer, but he doesn't have any experience in Rhino, Grasshopper, or the tools that we're coming out with soon called LandKit. So this interview is in three parts. It's talking about Topo kit, paving kit, and planting kit. Each of these is specific to a different whole area of landscape architecture, and I think it's a great intro for anyone who's curious about LandKit or about Rhino or Grasshopper. So enjoy. I am going to show you each kit. We're going to look at Topo kit, paving kit, and plant kit. This is sort of like just like a little preview of Topo kit and kind of an encapsulation of what Topo kit does. It essentially takes, let me turn on some of the markups. It takes some of these markups and it helps you build your terrain and from there get contours. Rather than trying to draw a bunch of contours and then try to model something. Instead, you're moving around very simple objects in space. Like the 3D manipulation is pretty straightforward, right? You're either drawing a polyline in space. So if we look at these paths, it's like polylines kind of moving through space. And, if we want to get really specific, like here I created some mounds from surfaces and then I grabbed the contours of those so that we could get a really nice specific kind of sculpting going on there. And a lot of these other places, it's not as important yet because we're at a fairly conceptual stage. But the other thing, other than these break lines, is the topographic features, as we're calling them. And those are stairs, walls, curbs, which are inherently topographic, right? They're changing the grade, right? And everything, the grading has to kind of revolve around those things. So why not have them be part of the equation when you're actually doing grading? And this allows us to model and design kind of at the same time in Rhino. So you're not just modeling, you're designing. And then from there you get your contours as a byproduct, rather than trying to sort of say, how's grading work and how do I do contours? It's really a way for you to like think fluidly and intuitively, which I know that you do, because otherwise I wouldn't have made you the designer in residence for a month or whatever, or however long you want to do it. But yeah, so the idea here is that with a wall, if you want to create a wall, you're basically just drawing. Let me turn off these areas. Oops. You're just drawing in plan your wall curves, right? Like you would in CAD. They're flat. They're just flat on the XY plane. Getting a little motion sick here. And then we're drawing spots, like just points in space. But if I say Control Tab, and I go into, I'm just kind of moving through the different views, the side view, the top view, and I zoom in here, I'm drawing a point, and it's near those lines in plan, but it's vertically elevated. And that the grasshopper is automatically pulling in stuff off of the layer that those are drawn on, right? So as long as we draw it here on the layer, give me a second. So as long as I draw that, there's the green wall layer, and I just drew those points there, or those lines there, and then I drew spots here, it pulls those in and then uses them as inputs in this very simple command that looks for all those curves and their proximity with the points, and it pulls it all together and builds a bunch of walls. And then it automatically figures out what's the top of the wall, what's the back of the wall. It figures out how to build the three-dimensional... actually, this isn't actually building the 3D wall. Later down the line, when we plug this into... over here, we can say draw wall. And that's a common thing where we're creating a lightweight kind of version of something. And it's not just a piece of geometry. It's actually this kind of more, encapsulated. It's almost like Revit, where it's like this smart object, right, that has data inside of it. And then we're drawing that object later down the line, and that takes longer. So this is what 138 milliseconds, and then this one over here takes 169. So if it was doing it all at once, it would be longer. I'm actually surprised that it's taking longer to draw it, or not as long to draw it, which is good. It means that the tools are working fast. But you can see these bright orange lines. Those are the break lines. So not only does it draw a 3D representation of the wall, but it also extracts out of that break lines that are then participating in the construction of the topography. Right?
And just, I'm not sure what does that mean, break lines?
Break lines. So rather than drawing, like if I look in elevation, contour cuts through at a flat elevation, right? That's why they call them elevations. Whereas a break line, well, in this case, these are technically contours for the mounds, but a break line is going to cut across, right? It's sort of anywhere. The way we treat it is anywhere where we want to kind of manipulate the terrain, fold the terrain, push or pull it. We're using these break lines. But you can also use contours in addition to break lines. So you could take a bunch of existing contours and then draw break lines in the places like swales or mounds or in other places in order to kind of clean that up. So actually, yeah, let's look under the hood so that you understand a little bit more about how this is working. If I turn on the mesh points, so these mesh points, what's happening is given these curves and maybe spots, it gets all the spots it needs from the curves, and then it's building a delinee mesh or a tin, as you might know from SketchUp, right? And that tin creates essentially a mesh membrane that represents the whole topography.
Okay.
Right? And there's a tool that does this. So down here, kind of like over here, we have this is drawing our different features, our walls, our curbs, our stairs, and paths. And then over here, we're kind of drawing the 3D representations of those. But down here, we actually take them. So this is all the features collected. See, they're all kind of funneled into this one container, right?
Okay.
And then they're used later. So the other geometry that we're using is pulled off of the layers, just like those wall curves and the spots that we were looking at to construct the walls. But here we define a parent layer. So in this case, it's Topo proposed. And then that layer, so let's look at that, Topo proposed. Underneath here, there's boundaries, break lines, mend lines, which we can talk about, other geo, which might be like if you wanted to sculpt a mound, you could actually have a mesh or a surface that defined a mound within all of this other geometry, so that it could be very specific, right?
Okay.
And spots, of course. And actually what's missing here is contours. But if I were to just make a layer, the syntax, there's kind of a syntax here. Like it's expecting these lines or these layers, and then it's going to treat whatever's on those layers in a specific way. Right?
Okay.
But it pulls all that geometry in and builds what we call a geoset. And the geoset is just this collection of all of the stuff that you need for that kind of layer of the topography, right? So because this is Topo proposed, but we could also add a revision. This geometry then gets used to create a topo object. And then we can use this other geoset to make a revision or a modification to that object. So it's kind of cool. Like, imagine like your boss gives you, like, they say, here's the drawing, here's what we're going to do. And then you do and that's the proposed, right? You build it all out, but then you say, what if we did this? And you can actually patch in a revision and then have them, kind of look at that, and they might be like, that's great. And then you can kind of integrate that into the proposed once it's kind of approved. But if they don't like it, you can just turn it off. We can bypass that. It's kind of neat. So let me just show you how that works. I'm going to turn off. I can minimize this just by clicking here. It's kind of nice. If I turn this off and I draw, where am I going to do this? I'll do this over here. If I draw a polyline under my revision boundaries, so I draw a boundary, and then I can draw another piece of geometry. Let's say this is let's say this is like a platform, like a little lunch area in the woods. I'm going to change this. Oops, I'm on the wrong break lines layer. I want it to be the break lines underneath revision. And then saying Control Tab, I can go to a view where I can move this up to the right elevation. And I'm just going to do this kind of intuitively, just for the example. But we move it up, and it's different than the terrain that's there, right?
Yeah.
And if I then just refresh, I have to hit refresh. And all of the buttons over here are just manifestations of buttons that are inside of Grasshopper. So you can hit either one. You can either go into Grasshopper, or you can hit a button over here. This is the Grasshopper panel. So if I just click refresh, give it a second, and it will update the terrain, right? It just changed that grading. And then I can turn on those mesh points again. And here you can see that, yes, there are points where the break line is, but there's also points where we drew that boundary, right? Where it's actually kind of clipping the old thing, right? So that the grade will actually change at that point. So if we took this and raised it up really high and then said, refresh, we get,
oh wow, okay,
so it does it right at that boundary. Now we, in order to kind of go the whole way here, we would probably want to draw a break line along that corner. So break lines help you whenever you see problems with the mesh, right? Whenever you run into things that are, because it's just sort of in trying to interpolate everything, and you don't want to necessarily have to draw anything you don't need to draw, right? So you kind of add break lines as you need them, right? So for example, if we were over here, this is a little wacky. Let me turn off the points so that it's not so. So if we go in here, we can see that we have these paths running through the landscape, along this slope. And then we have these modifications that we made to create swales, and we're just using break lines to do that. Right? We're just pulling them down to a point to create a funnel, to create like a low point. And that's to kind of create these like cascading rain gardens coming down the path. What else? Yeah, so the stairs are kind of similar creature. They're a little bit more direct, but that means the object that you're manipulating has to be, kind of just so. Just for now, anyways. This is a surface, and if I hit F10, I can turn the points on that surface, and I can move this up like a foot, and it will redraw all my steps. Now, the way that steps work is you give it a rise value. So it actually made more steps that are not as long. So you're doing a little bit of math there where you're saying, okay, I know I need 5 steps, right? And I know I want them to be 1 foot, so that they're going to be, I don't know. So you usually, you're going to have to do a little bit of math there. But the important part is it's controlling the topography and drawing you some steps at the same time.
Nice.
Right? It spits out break lines as just like the curbs and the walls. Let's actually take a quick look over here at curbs. Curbs are actually very similar to walls, because they're, it's basically like a high side and a low side. It's a little wall, just a cute little wall. But then you can add curb cuts, so you can add a modification. Just like you can add like a topo modification, you can add like a curb modification, which is in this case a curb cut, right? And the way that you do that is simply by drawing a center line. Let me show you how that looks in Grasshopper. So here, just like with walls, we have a bunch of curves coming in and spots. And then we plug our curb objects into this, and we're essentially taking those curb center lines, those curb cut center lines, with a few parameters. So in this, here I'm saying the run is 6 feet. That run could be 5 feet, and that should update over in my drawing. See that?
Yeah.
And you can change the flare, like how wide those wings are. And you could set this up so that you have like 3 different kinds of curb cuts, like that have different sizes, if you wanted, that have different parameters, and then just have a few different instances of this or different layers that they're pulling from, right? So depending on which layer you're drawing them on, it's pulling out, different locations to draw them, basically.
So if you want to do like you're saying a different curb cut somewhere else, do you add that curb cut component like below this one, or you're using that same component in Grasshopper?
So as long as all the parameters are the same, I can go to my features layer, all the topo features, that's like stairs, walls, curbs, curb cuts. So if I go to curb cut CL, that's where we're drawing these lines, and I say, okay, well, we're going to need another one here. And I just draw that there like that across the curb, and boom, it's there.
Oh, wow.
Yeah. And that's cool. Spitting out all the break lines that you need as well, to create the correct topography. So if we switched over to 1/10 of a foot contours, that's what the grading looks like. So it's almost like doing micro grading, like while you're in concept, right?
Wow.
Yeah, it's crazy. It's pretty smooth. But if you do this, you can also see immediately what's happening with your grading. You're getting kind of this immediate sense of the organism. It's like biology, getting a feeling for the organism and just really understanding like what your terrain is doing, right? I'm going to plug back in the 1-footers, and I'm going to turn on areas. Now areas, so typically how would you do all the different areas, right? So you make one mesh, you make the tin, and then you cut it up, right? And then if you got to make changes, you're screwed, right? You're just game over. So in this system, what we do is we have some kind of leftover lines here from drafting, but I'm going to turn on my areas, and these areas they're just surfaces. So unlike say SketchUp, Rhino has surfaces as well as meshes, and surfaces are essentially like idealistic geometries that then are actually previewed with meshes, right? So you can render them at different resolutions, which is kind of nice, but they're mathematically described, which means that every surface after it's trimmed can then be untrimmed and then joined with another surface, and it's very malleable. And what I like to do is use surfaces to trim. You just use the trim tool to split like a plane. So you draw like one plane, and then you use the lines to do a split. So you basically say, plane, here, I'll actually show you. So if you have a line running across, and I say, take this object. Oh, this is going to mess everything up. It's going to try to create a curb cut there. Okay. I'll draw it on no plot. I'll move it to no plot. With great power comes great responsibility. Make sure you're drawing on the right layer. So if you have, if I have this surface, surface that is describing an area in this case, and I say split, and then grab this line, and I actually have a set of shortcuts that I could share with you.
All right, cool.
And say split. Now I have two surfaces, and they're split. Right, and I can also grab both of them and say Control J to join them, and then I have a little quick command that sort of removes all coplanar seams and stuff. And I just say CB for clean brep. Brep is like another way of saying surface or poly surface. Hit return, and it removes all of the seams as long as everything is flat and joined together. And then it also makes sure that the surface that you're dealing with is only about the size of the thing that's trimmed. Because a lot of times if you draw this big thing and you trim it, you still have within each of those little pieces, you still have the big surface. So, yeah, it's kind of it takes a minute to wrap your head around, but a surface is always represented by kind of like almost like an X and a Y, which is U and V. It is referred to as U and V coordinates, but then you can have whatever shape you want to kind of cut that out, right? So you can't have like a surface that kind of goes three ways. It only really has two kind of crossing curves to describe the surface.
Okay.
That's a whole Rhino lesson there, but I just wanted to give you, as a kind of a non-Rhino user, like a sense of what that is. So I've drawn these surfaces. I basically drew them out, drew a bunch of lines, trimmed, split, whatever, to get them all the way that I want them. I can now manipulate them as well. I can say SP on, or actually, I'll do, that's my shortcut, solid point on. And I can grab that and move it around, right? So I can move the solid points and kind of manipulate it in plan. It works really well. If you start moving these vertically, it starts to really add a lot of detail to the surface, and that can be problematic, so I would avoid that.
So is it, if you move those points, is it pulling, are they all attached to each other?
These aren't attached. I grabbed 2 points at once.
Okay.
Yeah. So, and then if I, so then, that's how I'm describing the areas. They're all flat. It's very straightforward because it's just flat, right? You're not having to think in 3D with your different surfaces. You're not having to say, okay, first of all, here's all my areas, and then split my topography into that. Instead, what it does is it just has a component that just projects everything to the topography, right? So all of our meshes now are at elevation. And, this is going to be a little funky because it has such extreme, changes, but that could be also seen as a way of smoothing things out, kind of, having it not necessarily kind of break at that break line. But you could also just take that break line and split that area in order to get a nice clean change, right? You'd have a surface for that, a surface for the donut, and a surface for the kind of base area.
Okay.
Yeah, so that is areas. And the neat thing is I can then just say bake areas. So right now what we're seeing is just a preview. So certain geometries are in Rhino and certain geometries are just being previewed in Grasshopper. And if I hit bake, this clicks on a button inside of Grasshopper that brings and pulls that data into our file. Now, I had already done this earlier, but I can just show you how fast it is. If I bake again, it just updated this wall. because I had moved this up. And then you can also bake the walls, and the curb is out of date too, so I can bake the curbs. I could make this all one button, but there it goes. So the curb is updated in my model, and then I like to bake the current topo, because so what we're seeing right now is just the areas. If I hide those and hide these materials, I can see my singular. I still have this singular membrane of topography, which is this kind of mesh, right? And that I like to bake that as well into my file it's actually on a hidden layer here. But I'll use that later for things like planting and paving and other stuff like that. Because it's like the one thing I know I can always refer to as the topo.
And to get that layer, did you just draw like a box around the whole drawing and it just sort of just filled it in, or did you?
Sorry, to get the current topo?
Yeah, I guess does it just draw it around? Does it draw that surface or mesh around like where each contour ends? I guess is that what it's using to give it the shape?
Yeah, the contour is essentially, it's like when you do a tin, because it is basically doing a tin, which is like creating a delineé mesh. If you draw a point out to here, the mesh will extend out to that point, right?
Okay.
But there is also a boundary, so you can draw a boundary around where you want that particular